In this lesson, we are going to continue factoring trinomials with a equal to 1 and also making sure that we take out the greatest common factor. We are going to demonstrate this using the box method or reverse distribution. So remember that when we are factoring, we are actually reversing our multiplication, and we want to reverse this time of two polynomials or two binomials. So before, when we were multiplying, we took x plus 6 times x minus 5, and we multiplied x times x to get x squared, 6 times x to get 6x, negative 5 times x to get negative 5x, and negative 5 times 6 to get negative 30, and then we combined our like terms together, and that gave us our polynomial of x squared plus x minus 30. So our job is going to be, we are actually going to be given the answer, the product, the polynomial, and we want to know what did we multiply together to get that, and those are called the factors. We'll begin with this process. When we are factoring, we want to make sure we always take out the leading coefficient, and we want the greatest common factor, and we want the leading coefficient to be positive. Today we're going to practice factoring using both the box method and reverse distribution, and you'll get to decide which one is easiest for you. So, with our trinomial, a is going to be our leading coefficient. Remember, that's the number that's in front of our x squared. And we are looking at trinomials today where the a is equal to 1. So their leading coefficient is 1. So method number 1, the box method. So we're going to draw our box, and this time we do not know the dimensions that go outside the box, but we do know the answers that are going inside the box, and from those then we can find our dimensions of our box, which gives us our factors, or the numbers that we're multiplying together. So first of all, we'll put our x squared in our first box. What do we multiply together that gives us x squared? Well, we multiply x times x. That's going to be the first part of each of our binomials. Then we're going to take our last box, which is negative 21, and what we want to figure out is what two numbers can I multiply together that give us negative 21, so that when I add these two boxes together, I will get negative 4. Well, we do know that one of them needs to be positive and one of them needs to be negative in order to get a negative 21. So my factors of 21 could be 1 and 21. Would I be able to use 1 and 21 in a combination of positive or negative to get negative 4? Nope. So what else can I multiply together to get 21? I can multiply 3 and 7. Could I use a positive or negative combination of 3 and 7 to give me negative 4, which would be the sum or combining like terms of my boxes? Yes, I could. If I use a negative 7 times x is negative 7x. And if I use a positive 3 times x is a positive 3x. And 3 times negative 7 gives me negative 21. And when I combine like terms, which we always want to check to be sure that it works, negative 7x plus 3x gives me negative 4x. So my two factors are x minus 7 and x plus 3. Those are the two binomials I multiplied together to give me x squared minus 4x minus 21. Now the reverse distribution method goes like this. I set up my two sets of parentheses just like we did when we used the distributive method. And I say to myself, what can I multiply together that gives me x squared? And that would be x times x. And then I say to myself, what can I multiply together that gives me negative 21? So when I multiply the two, I get negative 21. But when I add them together, I get negative 4. That would be a negative 7, and a positive 3. And we do need to make sure to check our answers that we have the correct factors. So x times x is x squared. X times 3 is 3x. Negative 7 times x is negative 7x. These two, when added together, give us negative 4x, and negative 7 times 3 is negative 21. So this will be my two factors for my polynomial. And you can see, regardless of whether we use the box method or the reverse distributive method, we'll get the same answer. Let's try another example. So first thing we want to do is make sure that our leading coefficient is 1. And if it is not, we definitely first need to check for the greatest common factor. The only thing that these three terms have in common is 1, so we're good to go. We're going to do this one with the box method. So draw your rectangle, or your square, I guess, dividing it into 4 sections, and we put our first term in our first box and say to ourselves, what do we multiply to get x squared? We multiply x times x. What do we multiply together that gives us 6? Well, when we multiply together to give 6, these two solutions have to give us an answer of negative 5. So when I multiply the two together, in order to get a positive 6 but a negative 5, that means that both of my factors of 6 need to be negative, because a negative times a negative is a positive 6, but when I add two negatives together, it's still negative. Now my factors of 6 are 1 and 6. Will 1 and 6 give me a sum of 5? No. My other two factors of 6 are 2 and 3. If I multiply 2 times 3, I get 6, and if I add 2 and 3, I get 5. So I can make this a negative 2 and a negative 3. And it doesn't matter the order. You could have the 2 here and the 3 up here. Now let's check to be sure. Negative 3 times x is negative 3x, and negative 2 times x is negative 2x. So when I add these two together, negative 2x and negative 3x, that gives me a negative 5x. So my factors, my two binomials that I multiplied together, are x minus 3 and x minus 2. Let's take a look at example C. First, we're going to look for the greatest common factor, and the only thing they have in common is 1. We're going to use our reverse distribution to practice on this one. So we say to ourselves, what do we multiply together that gives us x squared? That would be x times x. What do I multiply together that gives me a positive 1, but when I add it together, I get negative 2x? Well, in order to get a positive, I either have to multiply a positive times a positive or a negative times a negative. And in this case, because I want my sum to be negative, I'm going to have a negative and a negative. And 1 times 1 is 1. So let's check to make sure this is correct. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And if I add these two together, I get negative 2x. And then negative 1 times negative 1 is negative 1. Now, when you have two binomials that are exactly the same, when you are writing them in standard form, please make sure that we write it one time and we mark it as squared to show that there are two of them, and that would be correct notation. Let's take a look at our next example. The first thing we want to do is to look for our greatest common factor. So our greatest common factor, we have a 6, a 48, and a 42. It looks like 6 will be our greatest common factor. So the first thing we want to do is to divide each term by 6. 6 divided by 6 gives me 1x squared. 48 divided by 6 is 8. And 42 divided by 6 is 7. Now what we would like to do is we need to factor completely. So not if we've taken out the greatest common factor, we still need to factor this trinomial. So let's do this with the box method. Our first box will be x squared, our first term, and we multiply x times x to get x squared. Then we fill in our last box, which is 7, and we ask ourselves, what can we multiply together that gives us 7, but when we add the two together, it'll give us 8x. 7 times 1 will give us 7, and when I add them together, I get 8. So this will be a positive 7 and a positive 1. And again, it doesn't matter which order we put these in. The 7 could be here and the 1 here. So let's check. 7 times x is 7x, and 1 times x is 1x. And when I add them together, I get 8x. So our final answer is first our greatest common factor, and then our two binomials, x plus 7 and x plus 1. And again, it doesn't matter the order. We could have written x plus 1 first, and then x plus 7. In our next example, we want to look for the greatest common factor. If we look at the coefficients, they don't have anything in common other than 1, but we do have a variable in common. So we'll keep the base. Now when we look at the exponents of 4, 3, and 2, we see that our smallest exponent is 2, and that would divide evenly into all three terms. So x to the 4th divided by x squared, we keep the base and subtract the exponents, which would be x squared. Then we have negative 9, x cubed divided by x squared is x, and then we have negative 36, and x squared divided by x squared is x squared. Now what we want to do is we want to factor our trinomial inside. So we draw our two sets of parentheses using the reverse distribution method to practice. X times x is x squared. Now, what two numbers can I multiply together that give me negative 36, but when I add them together I get negative 9? Now, because these are both negative, we do know that one of our factors must be negative and one must be positive in order to get a product of negative 36. Let's think of some factors of 36. 1 times 36. If I add these two together in a combination of positive and negative, will I get negative 9? No. Let's do 2 and 18. If I have one of these be positive and one negative, would I get negative 9? No. Let's try 3 and 12. If one of these is positive and one negative, will I get negative 9? Yes, negative 12 plus 3 would give me a negative 9. And don't forget that I need my greatest common factor as well, which is x squared. Now let's check to be sure that we have the correct factors for our binomials. X times x is x squared. X times 3 is 3x. Negative 12 times x is negative 12x, and when I add those two together, that gives me negative 9x, and negative 12 times 3 is negative 36. In our next example, let's look for the greatest common factor. So the greatest common factor, first of our coefficients, would be 5, and then of our bases, we do have a d in common. So we are going to divide each of our terms by 5d. 5d cubed divided by 5d, 5 divided by 5 is 1, and d cubed divided by d would leave me with d squared. Negative 45 divided by 5 would be negative 9, and d divided by d would be 1. So let's take a look at the box method to factor our binomial, which is inside of our parentheses, so that we continue to factor completely. First, we'll put our d squared in our first box, and remember that d times d gives us d squared. Then we want negative 9 in this box. In order to get a negative 9, we know that one of our factors needs to be positive and one needs to be negative. Now the tricky part is that there is not a middle term here, so these two boxes will need to have a sum of 0, which means they need to be the exact same number but opposites. What two numbers can I multiply together to give me 9 that are exactly alike? That would be 3 and negative 3. So we have negative 3 times d, which is negative 3d, and d times 3 would give me positive 3d. So if I check my answer, we do see when I combine like terms that those would have a sum of 0. So our final answer is our greatest common factor, which is 5d, and then our two binomials, which is d plus 3 and d minus 3. And those are the factors for our initial polynomial. In this example, again, we want to take a look at finding our greatest common factor. Our greatest common factor is found by first looking at our coefficients. And it looks like they have an 8 in common. But you do remember from previous information that we would always like our leader to be positive when we're factoring. So we want to divide out a negative 8 as our greatest common factor. And they don't have any variables in common. So we're going to divide by negative 8. Negative 8 divided by negative 8 is 1, and we still have an m squared. 32 divided by negative 8 is going to give me negative 4m. And negative 32 divided by negative 8 is going to give me a positive 4. So let's use reverse distribution on this one. So what do I multiply together that gives me m squared? M times m. What can I multiply together that gives me a positive 4, but when I add them together I get a negative 4? Well, that will mean I can't multiply a positive times a positive, because when I add two positives together, that would give me a positive answer. I want to have two negative numbers that I multiply together to give me a positive 4. What are my factors of 4? Well, I have 1 and 4. When I add those together, will that give me negative 4? No. But I can multiply 2 times 2, and when I add them together, I can get 4. So this will be 2 and 2. And we have our greatest common factor. Two things we need to talk about. One, we better make sure to check our answer. M times m is m squared. M times negative 2 gives me negative 2m. Negative 2 times m is negative 2m, and when I add those together I get negative 4m. And negative 2 times negative 2 is positive 4. We also want to rewrite, making sure we include our greatest common factor, and because the factor of m minus 2 is the same and repeats, we want to rewrite it as a square. So these are the factors of our polynomial. To review, remember factoring is really reverse multiplication. We want to know what did we multiply together to get our product. Always factor out the greatest common factor first. When you're factoring trinomials, you can use either the box method or reverse distribution, whichever is easiest for you. And if two factors are the same, we want to write it squared. X minus 10, we'll write it as x minus 10, the quantity squared. Please remember to complete the reflection.